Let's talk about Project 1, Lesson 1, Question 1. Daisy purchased a rabbit couple to keep as pets. Perhaps Daisy got more than she bargained for. If the population of rabbits doubles every 3 months, how many rabbits will Daisy have at the end of 3 years? Okay, think about the question before you start working. What are we being asked to solve for here? Well, we're given some information, and our goal is to figure out how many rabbits will be in this population at the end of 3 years. Now let's consider what we know and make a plan. Well, we know the number of rabbits that we're starting with. She purchased a rabbit couple, meaning we're starting with 2 rabbits. And we know what double means, but let's clarify it. So if I double a number, I'm multiplying it by 2 or I'm adding it to itself. Now think about the number of times this population is going to double. Rather than straight out calculating how many doublings we're going to have at the end of 3 years, let's just start by thinking about how many times that would be in 1 year. So if a population doubles every 3 months, how many times will it double in 1 year? Another way of asking that would be to say, how many 3-month periods are in a year? Well, I know that 1 year is equal to 12 months. And I want to know how many 3-month periods are in a year. So if I divide this by 3 months, it's pretty easy to see that there will be 4 3-month periods in a year, or 4 times that this population doubles within a year. Knowing that number, I can then ask myself, how many times will this population double in 3 years, which is really what I'm trying to get at. Now, I'll leave that for you to solve. How many times will this population double in 3 years? Now, say, for example, that we did only want to calculate 1 year. Now, again, that's not what the question's asking, but just for sake of example, let's talk it out. So let's say that we were asked how many rabbits there would be in the population at the end of 1 year. Well, there are 4 3-month periods in a year, so I know this population will double 4 times. So I've got my starting number of 2 rabbits, and it will double 4 times. So I start with 2, I double it, that's the first time, second time, third time, fourth time. So notice this is actually 2 to the 5th power, right? 2 times 2 times 2 times 2 times 2. It's tempting to write it out only 4 times because you're thinking, okay, I've got 4 sets of doubling, but you have to account for the original 2 rabbits that you started with, so this is incorrect. So 2 to the 5th would be the number in the population after 1 year. Now I would multiply that out and get my answer. You'll take it from here and tell me how many times the population will double in 3 years and use that information to figure out how many rabbits Daisy will have at the end of 3 years. Be sure to write out the actual number. If you're doing it in exponent form, solve it. Don't leave it as an exponent. Now let's talk about question 2. Question 2 says, some scientists estimate the growth of a population using the Malthusian model, named after the Reverend Thomas Malthus, who wrote one of the most influential books on population. His formula uses the natural logarithm, which you will learn about in a future lesson. So this is all background, but not important to answering the question. So let's focus on this information below. Another formula that models growth is shown, where n sub 0 is the initial size of the population, n is the final size of the population, r is the rate of growth or decay, and t is the number of time periods. In this case, r equals 100%, or 1. Using this formula, how many rabbits would Daisy have after 3 years? Okay, so notice that we are being asked the same question. We have the same situation with Daisy and her rabbits. It's the same amount of time. So think about what that means for what your answer for this question would look like and what your answer for the last question would look like. Now, this time we're asked to solve using this Malthusian model. Think about the information they've given us. So they've told us that n sub 0 is the initial population, n is the final size of the population, R is the rate of growth or decay, and T is the number of time periods. So which one of these is the variable that you're solving for? Well, we want to know the size of her population after 3 years. So n is what we're solving for. We want to know the final size of her population. We're able to set up the rest. So I know that n will equal n sub 0, the initial size of the population. So how many rabbits did she start with again? Well, 2, right? She purchased a couple. So 2. It tells us straight out that R is equal to 1. And this is because the population is doubling, which means it's growing by 100%. So for example, if I start out with my 2 rabbits and I double the number, that means I'll have 4 rabbits. So my population has grown from 2 to 4, which means my population has grown by 100%. 100% expressed as a decimal is 1, so that's why R is equal to 1. And finally, T is the number of time periods. Now you should have already answered this in the last question. Remember we asked how many 3-month periods are in 3 years? That same number is what we would plug in right here. Once you have your exponent, you'll be able to continue solving this equation until you simplify and get an integer for n. And again, think about the way that this answer should relate to your answer from question 1.